Hello, this is Math Fun 40, day 14. There's a ton of topics in the current homework about lines and linear functions. So let's do a chunk of those. To begin with, we're talking about functions that can be written like this. mx plus b. M and b are constants. X is the input variable. So it's a degree 1 polynomial. And we would also allow that the m could be 0, that it's a constant function. In that way, you get all possible straight lines as graphs of these functions. Graph of such a function is always a straight line. And it can be any line except the vertical ones. And we'll see in the course of this module how that all hangs together. So what can we do with that? What's the deal? To begin with, we can specify a line in many different ways. We can specify with an equation like this, but we can also specify a line by 2 points on it. By default, my lines are always straight lines, I should say that. Points on it, and it's a natural question. Find me an equation like this one above for a line passing through the line, passing through 2 given points. And for that, it's best to first look at the geometrical meaning of those parameters m and b. So let me sketch something. Some random straight line. Where in the picture can you see the b? And the answer is, when you substitute x equal to 0, then you get f of x is b. So that is specifying this point on the graph. Coordinates are 0, b. And this is how you can geometrically see this this point, sorry, the value of b. What about the m? How can you spot m? And here the answer is, you take any point on the line and you walk 1 unit to the right, then your y value, the f of x, will have increased by m. Like this. But you can also walk a multiple of 1. You walk 2 units to the right, and your y value has increased by 2m. And generally, you walk any number of units to the right, get to another point with a new x value. Say the first x value is called x1, second x value is called x2. So the distance we walk to the right is the difference, x2 minus x1. What happened to the y value in the process? So that's the difference between the y value at the beginning and the y value at the end. At first, say we had y value y1. This whole point is x1 comma y1. At the end, we got the point x2 comma y2. And that difference is therefore y2 minus y1. And the ratio between those two differences is m. Always m for that given line. Why is that so? You can plug in x1 and x2. So you get y1 is mx1 plus b, y2 is mx2 plus b, and you subtract one from the other, the b's cancel out, you factor out an m, and you're basically there. So subtract the first from the second, and you get y2 minus y1 is m times x2 minus x1. And then you can divide by x2 minus x1, and you've got the boxed formula up there. This number m is called the slope of this line. And the b, what I'm at, is called the intercept. And now, surprise, when we write f of x is mx plus b, that's called the slope-intercept form of an equation for such a line. There's other forms. Slope-intercept form of an equation, or slope-intercept equation. All right, so back to this original question, what do we do when we have two random points on a line? How do we find this slope-intercept equation? Given a line through 2 points, 1, 4, and 3, -2. Find the slope-intercept equation. So we have to find the m and the b. More interesting part is finding the m. Remember that box formula? y2 minus y1 divided by x2 minus x1. Burn that into your brain. It's amazing how many people mix this up, at least in an exam situation online. You can look it up in your book or in Alex or wherever you want, but this really should not something you have to look up. So in our case, we take two x values. That'll be our denominator, the difference between them. And I'll take x2 minus x1, that's the 3 minus the 1, right? The x values are named first in my coordinates, x2 minus x1. And then the y values, the y2 comes first, so that's the negative 2, minus y1, that's the 4. Which gives me negative 6 over 2, which is negative 3. That's my value for m. That's the slope of this line. And then find the b. I know at this point already, it's going to look like y is negative 3x plus that unknown b. And when x is 1, y needs to be 4. X is 1, then y is 4. Plug in those values. You plug in 4 for y, 1 for x, and that should help us find b. You can solve that equation for b. B is 7. And we're home high and dry. Reality check. Had we plugged in x is 3, then what would we get? Y is negative 3x plus b. We should have gotten negative 2. Let's try that out. Negative 2 is negative 3 times 3 plus b. And it also leads to b equal to 7. Great. Mathematics is consistent. You can find the right answer in several different ways. Okay, last bit. More general form for the equation for a line that's called the point slope form. Given a random point, let's say x1, y1, and the slope for your line, we can write an equation for the line specified by those two data or those two properties. And I would write it like this. I would write y minus y1 is a given number, equal to m also given, times x minus x1. So in other words, I'm just treating the x2 and y2 as variables, input and output. I'm writing x and y for them. Y1, x1 are given, and you let the x run wild, and then the y which comes out of that gives you the y coordinate for the point on your line. So as an example, find the point slope form, PSF, for the line through the point 3, -2 with slope -3. And the nice thing is you can just write it down. There's no computation necessary. You just need to go take the y value. That's a -2. And you need to subtract it from y. Y minus -2 is the slope, -3, times x minus the given x value, x minus 3. And there's always people who want to simplify that and simplify until you get to the slope-intercept equation, which of course is the same as before. I'm recycling that example. And all I'm saying is you don't have to. If you just ask for a point slope form, this is perfectly fine. And for some applications, it's actually better to leave it like this because you're maybe really interested in that 0.3, -2 and what happens for x values close to it, close to the 3. And for those purposes, it really is better. So definitely my favorite form. And well, if your x1 is 0, so the x value of the given point is 0, then we rediscover y minus b, that's the y coordinate, which belongs to x1 is 0, equal to m times x minus 0, don't need to write that. So that's, to my eyes, pretty much identical to the slope-intercept equation. The slope-intercept equation, might say, is a special case of the point slope equation. And there's many different point slope equations possible for the same line. So that's one thing which is not so nice about it. You can have two different equations. They give the same line and you can't see it with the naked eye. The slope-intercept equation is good to compare different equations. And if those are different, the lines are different. But oftentimes the point slope is just what we need. Okay, more examples in lecture. That's it for today.